having another look at the Geospatial Technology Competency Model, which has been around for a long time. It's by the U.S. Department of Labor, but they list different competencies that they think are important for a career in geospatial. And, I always try to remind myself of some of the things that are there, like interpersonal skills, integrity, professionalism, reading, writing, math, communication, critical and analytical thinking, teamwork, creative thinking.
Welcome to another episode of the Mapscaping Podcast. My name is Daniel and this is a podcast for the geospatial community. My guest on the show today is Don Boys, and he is a professor at the University of Toronto in the Geography department. And today on the podcast, we're going to be talking about GIS education and training. This podcast episode is sponsored by landgrid.com. So if you are in the market for property boundary data for the entire US, you need to get yourself along to landgrid.com. They have an API, a tile server, you can bulk download this data, they have a data store, so there's lots of different ways of getting at this data. They even have a few free options, so if you just need to make a few simple lookups, go to landgrid.com, you can do that for free. They also have a free mobile applications, so check that out if that's something you're interested in. Landgrid.com, there will be a link in the show notes. Okay, let's get on with the interview. Welcome to the podcast, Don. Thank you for taking the time to do this interview with me. I really appreciate it. So today we're going to be talking about GIS education. We're going to be talking about in-person education, so the kind of thing that happens at a university, and we're going to be talking about the kind of education we can get online. So you have a lot of experience in both of these fields, but I think just before we dive into the conversation, perhaps you could take a couple of minutes just to introduce yourself to the audience.
Sure. Thanks for having me, Daniel. It's great to be here. So I'm a professor in the teaching stream in the Department of Geography and Planning at the University of Toronto in Canada. The teaching stream means that I focus strictly on teaching as opposed to having a research program as well, which is to my liking. I like the fact that I get to teach a lot of GIS. U of T has about 93,000 students, so it's a pretty large school, and we're ranked usually around the top 20, 25 in the world, so it's a good place to work. I took my first GIS course in 1988, so it's been a while. Over the years, I've used a variety of different GIS software in different ways. I did my master's and PhD in the Western Arctic. I did a lot of field work up there. I ended up consulting up there for quite a while I was in school and then afterwards. So I consulted full time for about 2 or 3 years, and then saw an ad for a job at the University of Toronto, decided to apply kind of on a whim and ended up getting it. And I've been there ever since. So that's been about 20 years now.
So like I said in the introduction, you have a massive amount of experience in this. I don't think you mentioned your online teaching experience there, but we'll get to that later on in the conversation. You said also that you had a PhD. I get a lot of people asking me, should I get a master's? Should I get a PhD? And just before we sort of move on, what are your thoughts around that? What do you do when a student comes to you and says, hey, I'm really interested in a career in geospatial and geography, and I'm not sure if I should get a master's or if I should go all in and do a PhD?
That's a great question. It really depends on where they see themselves going or what their goals are for their career. And I basically start by asking them about that, like where do they see themselves in 5 years or 10 years? A master's is something that you can do relatively quickly now. It's usually 1 to 2 years. There's even some kind of master's of GIS programs now. So that's not a big problem, or I don't sort of have an issue kind of recommending doing something like that, because I feel like if you got your undergrad, you want to do a little bit more, you want to be able to kind of dive in a little deeper into a particular aspect of GIS, then absolutely I would say a master's is probably not a bad idea. And it is a fairly marketable degree. So if you're looking for jobs, the fact that you have one is something, generally speaking, something that employers would see as attractive. The PhD is a whole other thing, though. It's such a huge time commitment and requires so much sacrifice in terms of time, money. If you're going through, usually when people are doing their PhD, they're at the age where they might be thinking about starting a family. They're seeing their friends going off and starting their careers, making money. And it's a long haul. It takes, I would think, at the very minimum 4 years. Often it's 5 or 6. So I don't discourage people from considering a PhD, but I think they need to know what they're getting into and what they might get out of it. So if they're thinking about going into academia, that's one thing versus using it for if they want to go into consulting or government or something like that. I honestly wasn't sure what I was going to do with it. To be honest, started my PhD because I was unemployed and had nothing else to do. And um, liked learning and liked being in a university. And I thought, I'll go start this and see what I think of it. And I think I had to start that way because it was such a daunting thing to get into. I thought, I'll just take this one step at a time. And of course, I ended up really enjoying it. I did decide I wanted to stay and finish it. And so for me, it was obviously something I'm really happy I did, but it's definitely not for everybody.
Yeah, I can completely understand that. I think the people that I saw doing PhDs when I was at university, I mean, the time commitment was something else. It really was. I mean, you have to be fully devoted to this. And it's one thing to do the exciting research. I think it's a whole nother thing to write about the research. And then I actually saw some of them struggle to get jobs afterwards because they were so qualified. And I think employers have this idea that, oh, that this PhD student, we will never be able to stimulate them, because they know so much. I think it's something that people really need to think about before they make that time commitment.
I absolutely agree. I mean, even when I started my PhD, I had already had my eyes set on being a consultant. I, at the time, honestly had no desire to be an academic. I didn't think that was for me. And so to me, I thought, well, this will make me more qualified as a consultant. I'm going to work for myself. So I wasn't so worried. I mean, I completely agree with what you're saying. There can be this perception of being overqualified depending on what you're applying for. But I actually asked a couple of consultants that I knew that I admired who were senior in the field, and I said, should I do this? And they said it absolutely won't hurt you if you're consulting. So it does depend a lot on what you're planning to do. But if I had decided I wanted to be a professor from the beginning, that is a very competitive market now. It's very difficult to get in. And so it's not impossible, but I just think people need to know when they go into this, what they might get out of it or what they may have to end up doing if they don't get into academia. Is there a backup plan that they're happy with?
I really appreciate you taking the time to put a few thoughts around that for us. I think that'll help a lot of people out. When you think about students now, so we're talking about this in-person education, the kind of education that's happening at universities. Do we see any trends? Like how do you see what they're learning? How has that changed over time in terms of their spatial thinking and like their understandings of geospatial concepts and technologies?
Great question. It's funny. One of the things that I think about is how they're being taught as well as what they're being taught. And I think this relates to what you're talking about is when I was when I was learning GIS, and probably when a lot of people were learning it in the past, say 10 years ago or more, data was relatively scarce and valuable and expensive. And so often when I was putting together assignments, when I first started teaching or when I was learning GIS, you'd get one data set, you'd give it to the entire class, and you would say, okay, here's the one data set with the one problem. Now you all sort it out the same way, figure it out, and solve the problem. And of course, it's usually some classic, fire station distance thing or whatever. And the thing that I've really realized over time is that has completely shifted, that with the open data movement, with things like the ArcGIS online portal, there's such a ubiquity of data now. There's so much more data out there that's available that's not the way we have to teach anymore. I don't think that's a good way for people to learn. So to relate to that, what I've tried to do more and more is to let students explore the data themselves from the very beginning of what I'm teaching them in an introductory course. So I will try to give them opportunities as much as possible to find their own data on the topics that interest them for the geographic area that they're interested in. Like maybe it's where they live, or maybe where they want to travel, or maybe where they want to work at some point. And so to me, kind of broadly speaking, that's been a huge change, a big shift, is to be able to have that ability as an instructor to say, go find some data, and of course I have to, teach them how to find data and how to evaluate that and to understand good data versus bad and what's an authoritative source and what's metadata and all of that. And for them to appreciate the fact that it can be messy. There's no getting around that. But I think the earliest opportunity we have to allow students to make connections to their own interests and their own lives, the more they'll see the relevance of what they're learning, which is huge for motivation. So that's kind of the big picture aspect of it. And I think from their point of view, they just take for granted that there's tons of data out there. That to them, it was never a question. Of course, there's lots of data. And of course, there's access to all kinds of great software and with amazing tools. And having the benefit of a fairly long career now, I remember the days when, raster GIS software was separate from vector GIS software, and remote sensing software was different. And now there's such a integration of all of these tools, and the interfaces are so much better. It's the kind of barriers for entry are so much lower, that I think that they just have a different perspective coming into it. So that's kind of the big picture aspect of it. And then there's trends, of course, related to things like big data, data science, machine learning, artificial intelligence. But those are things that I think are much later in an educational sort of process, let's say, for a student, than what they're starting out with at the beginning, which is still pretty much the introductory things we probably all know and love about, what's a map and what's a coordinate system and what's a map projection, and those kinds of things.
It's really interesting that you mentioned that, because I mean, we all started there, right? We all went through the tutorial, the practical lab sessions where you sit and you get a data packet and you work your way through it, and often the result of those practical labs was a map, some sort of cartographic output. Is this still relevant? And in a time where we have data everywhere, we also have more than enough opportunities to use lots of different kinds of software. I feel like there's so many companies out there working hard to democratize everything around spatial. Are these skills still relevant, or can we jump over them now? Can we move on to the big data, to the machine learning? Do we still need this grounding in spatial thinking?
I think so, yes. I mean, there's I think you have to start with the fundamentals. As I tell my students, is that when you're learning these tools, you have to constantly be thinking, well, how would I apply them to my context, to my problem? What am I interested in? And I think we're still, a long way off from AI, for example, kind of taking over or doing a lot of this work for us, that we still at this stage need humans to understand the context of a problem, understand all the things that could go wrong, to explore data. I think AI and machine learning can help in that process, and it's opening up lots of new potential and can automate things and can help us see things we couldn't see before. But there's still definitely a place for understanding what it is you're trying to do. I mean, a simple example, I know this isn't exactly machine learning, but I think it illustrates a point maybe, is I teach a section on raster weighted overlay. I kind of go through the basics of how it works and how you set the weights for different layers. And I give examples, the typical kind of constraint analysis for citing a landfill or a store or whatever it happens to be. But I always emphasize the fact that the weightings is what makes it all work. And the weightings are based on expert knowledge, that they have to know why they're assigning weights to something before they put it all together, right? Otherwise, it's the usual garbage in, garbage out. So I think that's still, I think that's still relevant, is that, as an example of that is just understanding the context, the perspective, the variables, what to leave in, what to leave out. There's still definitely room for that.
Yeah, and I realized that I was baiting you a little bit there, but I just want to hear you say that and really clarify that for the listeners, because I think this is incredibly important. I'd be curious to know now, if we stick with the idea of democratization, is it just geography students which are using and learning and interested in these kinds of skills and concepts, or do you see a wider sort of range of students focusing on it?
One of the great things about the courses that I teach are that I get students from all over the university. And I mean, we can talk about the online courses in a minute, I suppose, but just within the University of Toronto, I get students from all over the place. And I also teach an introductory course specifically for graduate students. And they're even more kind of interesting in a way, because they're already doing research. They're already trying to figure out how to use GIS in their work. And so I get students from, architecture, civil engineering, Near and Middle Eastern studies, you name it. Like, there's all these different disciplines that are using it. And I've always really had this open kind of welcoming attitude to them, is that the last thing I ever want to be is a gatekeeper for these people. I want them to be able to come in and see that they can learn this stuff, that I literally start from the very beginning with my introductory courses at the undergraduate level and at the graduate level. Is, I literally start with, what is a map? Why do we use maps? It's a form of communication. What does that help us do? And we kind of take it from there. So I think, like anything, we want to have people that are making informed decisions and know what they're doing and know how to use the tools and how to think critically about these things. But I absolutely welcome, people from all kinds of backgrounds.
You mentioned just before your online course. I think now is a great time to jump over to that. Would you mind just taking a few minutes here to explain where your online course is, if you have many of them, and perhaps what it looks like?
Sure. So I taught my first online course at U of T about 8 years ago. And it was really just kind of a fun experiment at the time. I mean, I'm kind of a techie person. I have a bit of an interest in photography and video anyway. And I thought, this could be kind of fun to kind of try something different and give students different options as to how and when they learn. I started off with just a really basic, voiceover PowerPoint kind of thing. It was certainly not exciting or particularly great, but it wasn't bad. And then I started to experiment with different ways of doing things. So I quickly realized that what actually worked really well was to do kind of a hybrid approach where I would live stream my course from the lecture hall. So I'd be lecturing to students in person. If they wanted to come to class, they could come in person. If they wanted to participate through a live stream online, they could do that. And then I also recorded it, and they could treat it as an asynchronous or time-shifted online course as well. And so over the years, I've done various kind of versions of that. I've done courses that are strictly online. I've done ones that are this kind of hybrid approach. And then I've taught, I have an introductory GIS course, intermediate, advanced, capstone. So there's kind of a sequence of them. The first three I've taught either as online or hybrid. About a year and a half ago, I launched 4 Coursera courses through their, specialization program there, where basically I created 4 courses that are in a sequence as well that I teach for Coursera.
So, for those people that don't know, what is Coursera?
So Coursera started in about 2012. Actually, it's right around the time I was teaching my first online course, and they were part of a movement of what at the time were called massive open online courses, or MOOCs. And it's funny because at the time there was a lot of hype about them. Coursera was one of the first big players. There was a competitor. Coursera was for-profit. Their competitor was MIT and Harvard, which created a nonprofit called edX. And the idea originally was to allow people around the world open access to learning content and courses hosted by, let's call them prestigious universities. And so that they would be able to kind of democratize the learning process by allowing everybody in to learn. So over the years, they've evolved. MOOCs kind of went through this hype cycle where they were huge. And, the New York Times was declaring that they were going to be a huge disruptor to higher education. That didn't turn out to be the case. And I've noticed in the last 2 or 3 years that the term MOOC is used less and less. And, Coursera and others kind of just think of them or market them as online courses. So the massive and the open aspects of them maybe are not as, emphasized as much. But that's kind of generally where they are. So Coursera has, over 40 million people that are learners, as they call them, on the platform. They have thousands of courses. I think there's about 150 universities that are partners with them. And so the idea is I'm an instructor or professor at a university. So I create a version of one of my university courses, one or more of them, and then they are partnered. So my university partners with Coursera. Coursera becomes the hosting platform, and they help structure it and put it together in the way that they think works best. And then they market those courses to students.
So I think this idea of online learning is incredibly interesting because it seems to me that a lot of us, we spend a great deal of time at university. So for me personally, that meant 5 years. A bachelor in New Zealand is 3 years, and then I did a 2 years master afterwards. 5 years of learning, and then I felt like my learning kind of stopped. I went out into the workforce. Of course, there was a whole bunch of other things to learn, but that sort of technical side of the geospatial world, that really in-depth analysis, and when different technologies showed up, I found it really difficult to find time to learn them, but it was incredibly important. I mean, we all realize that things are moving faster, more and more technologies are showing up every day, and some of them are going to be very significant. So I'm really excited about this idea of learning online, but I have never taken an online course. Is there something, and I'm sure other people are in a similar situation, what should we know before we sign up for something like Coursera?
Online learning is not for everybody necessarily, but I will point out that there are, like teaching in a classroom, there are good online courses and not so good online courses, right? So it really does depend a lot on how they're put together and what the course design is, and what the instructor is like. So I think the kind of generally speaking, you can have a really amazing experience with an online course, or maybe not one that's so great. And it depends on how you're taking an online course. So Coursera has, there's some really great things about it, and there's some limiting factors, let's say, for learning that way. So the great thing is that the courses, much of the material, I believe, is still freely available. So if you want to watch some of the videos, you can do that. You can access a fair amount of the content still that's free, but they are really trying to encourage people to pay, right? So there's a monthly subscription. They kind of keep tinkering with the course model. There's different ways of going about it. But the reality is that they are trying to keep these courses massive. They're trying to make them large. And so you may have thousands or tens of thousands or even millions of students taking one course. And so as an instructor, when I'm designing it, I have to design it to scale, right? So I have to essentially make it as automated as possible. Now, that's not necessarily a bad thing. I think we can do a decent job by doing that. But essentially, a lot of the time, it's watching videos, completing multiple choice quizzes, and then depending on how it's set up, like when my course is, each course ends with a little mini project, which is peer reviewed by other students, so that you do get a chance to do something other than a multiple choice quiz, where you actually get to create an artifact like a map or something else, and then show that to other people and get some feedback on it and have it assessed in some way. So I think that you can learn a lot that way, but that is, I think, a fairly fundamental difference from, say, taking a university course where my students at U of T get a lot of time to interact with me and with each other and with the teaching assistants, and they're getting a lot more feedback that's much more customized and more in-depth. And I would say the level of assessments are a little more rigorous, a lot more rigorous at a university than they would be through Coursera. So that's, they're different things. They're meant for different purposes. I think you can learn a lot through something like Coursera, but it's good to kind of, try them out and see what you think of them and see if it's working for you.
That's really interesting. So, so you definitely don't see this as a replacement for a university education in any way, shape, or form. At least that's what I heard you say. But it sounds like it's more of an enrichment of an education. Can you see, or can you think of any particular things which are really well suited to this? So I'm immediately thinking technical skills. I'm thinking programming languages, that kind of thing. Is that what online education is really great for?
It can be. I mean, it really depends on who you are and what you want to learn. So, for example, Coursera does have an emphasis on a lot of courses related to things like programming, learning Python, R, data science, things like that. So, definitely there is a lot of interest for people to upskill for professional development. And I do think that there are ways that can be done well. It can be challenging. For example, with my courses, students are using ArcGIS, and so they have to access that in some way. They have to install it. As if anyone's used ArcGIS before, which I'm sure a lot of you have, then you know that it can be sometimes a little tricky to install. If you've never, imagine somebody sitting at home trying to figure out how to install it on their own, and then they get an error or something goes wrong. So it can be a little bit challenging from that point of view. It depends on the course, though, right? So the good part of that is that they can actually learn with real software, real applications, trying things out for themselves. And then there's other courses like, say, a Python course where they have these amazing, kind of modules built into the Coursera webpage where you're actually doing the coding inside that page, so you don't have to install anything. So it can work really well. I think there's variations on how this is implemented. But yeah, it can be a really useful way to learn.
So I think the pandemic has taught a lot of us that we can move a lot of our lives, our professional lives, online, but not all of it. Not everything works really well online, but learning seems to be there's plenty of opportunity for that online. And I'm a firm believer in that we can learn almost anything we want. If you go to YouTube, somebody has created some content around it. And oftentimes with these online courses, from the little bit that I understand about them, I feel like perhaps one of the things we are paying for when we commit to paying for something like a course in Coursera is the structure that somebody has been through and filtered the material and structured in such a way that we can learn it. And I also feel like it's the accountability that we're paying for. Does that sound like a fair sort of understanding of it?
Yeah, I think that's a really great way of putting it. It actually reminds me in a similar way of writing a textbook, right? Is that you're getting the product of somebody who is an expert in the field and has kind of looked at the landscape of all of the things that could be put into a course and decided what are the key topics, what are the key concepts, what order do I put them in, how do I explain them, what examples do I use. And so it really is related a lot to that person's experience, their ability to teach, even their personalities. And so that, can vary a lot, but I totally agree. And I actually think of the content that I create through, especially through videos, as kind of a form of a textbook, that I'm creating a library of material that students can access and learn from in a lot of different ways. So, I don't expect them to watch all of them, just like you wouldn't necessarily expect someone to read an entire textbook in one sitting, but I want to create things that are of use in a useful, digestible, easy to follow format.
I'm wondering if you could give us any sort of stats or comparison between the amount of people that start a university education or a particular course perhaps and finish it, and in an in-person environment, in a university setting, and online. Is there anything there? Can you see sort of any overwhelming differences between the two?
Yeah, I can. I mean, I think so. I'll start with my university students that I have in my own department. So, I've mentioned I teach a sequence of courses from introductory to intermediate to advanced to a capstone. And so we start with about 500 students a year in the introductory course. And then we get with about, I don't know, maybe 100, 120 in the second course. And from those, we get down to maybe 50 in the third course. And then in the capstone, there might be 20, 25. So when I was designing the curriculum for that, I wanted to keep that in mind, is that I don't see that necessarily as a bad thing. It's that there's lots of students who want to take one GIS course, they want to learn a little bit about it, and that's it. And so, I had to design the first course and say, well, if this is the only course somebody takes, what would they need to know and why would they want to know it? They're not going to become a GIS expert, but they want to have some understanding of kind of the basics so that if they go and look at a map in the future, they can have a critical understanding of, is this a good one or a bad one? What was the thought process that went into it, and so on. So I think that we have to kind of keep that in mind, is that it's tempting to want to teach to just the hardcore GIS nerds, right? Like the ones that are going to end up in careers in GIS. But I don't really see it that way. I want to help people learn as much GIS as they want to know. And that might be one course or two courses or three or four. So that's kind of my attitude. I'm happy to welcome them in to more courses and to make that as kind of barrier-free as possible. But they have to decide how much they want to learn. So that's in my university environment. In Coursera, the completion rates are lower. I think I checked today, my completion rates are hovering somewhere between about 10 and 12%, which I believe is actually not too bad for Coursera courses, which is fine. I mean, I think some people make a big deal about the low completion rates as though that's a problem, but it goes back to the analogy I have of creating a library of content or it being akin to a textbook. Is a lot of people have no intention of completing these courses. They just want to learn a certain thing. They just like you would go to YouTube and learn what you need to know about fixing your leaky faucet or something. People go in, they learn what they need to know. If they like it, they might keep learning. They might continue and complete the course. But they may just decide to kind of come in and get as much as they think they want, or maybe they decide it's not really for them. So that's fine too. Like I said, I try to make it as kind of open and inviting for people as I can, but they have to decide how much they want to learn.
Yeah, and I think that's a great analogy with YouTube. And no one goes to YouTube, watches one video, and then watches all of the videos on how to fix your leaky faucet. No one arrives at a website and says, oh, I've read one page, therefore I better continue to read this entire website. And this is an idea of just-in-time learning, where I'm just learning the thing that I need right here, right now. I'm solving the question. And of course, Google is an amazing example of this, right? Like solve my, tell me the answer to this, please, Google. I get it. And then I don't continue reading. I go away and I solve the problem because I have the knowledge.
Exactly. Yeah. Yeah. I mean, the other analogy with the textbook is like if you read one section or one chapter and then put it down, it's not like you failed or why didn't you read the entire thing? It all depends on what you're looking for.
So I remember when I was starting my education and starting to learn about spatial thinking and geospatial technologies, and I was really excited about particular parts of it. I could look ahead in the future. I really want to learn that thing over there, but I had to wait. I had to go through a certain amount of courses first and pass them and finish them to a certain standard, and then I could move on slowly but surely. Do you see anything like when students start their educational journey, are they in general more excited about different things? Is it the map side of it that they see a lot of or they have a lot of excitement around, or is it the spatial analysis side of it? Is it perhaps the programming side of it? Is the visualization side of it? Is there any one thing where you feel like students are more excited about it when they first start learning about these different kinds of technologies?
It's funny because I try the very first day, the first thing I say on the first day in my first introductory course is I don't go over the syllabus. I don't talk about, the exam or anything like that. I literally start by saying, what kinds of questions can you answer with a GIS? I don't even really talk about what a GIS is to begin with. I just say, if you had a map and you wanted to know something, how could you do that? What kinds of questions could you ask? What would be the thought process you would go through to answer that question? And I do really try to hook them from the beginning with this idea of, their questions and their interests and what they need to know. And that I'm going to give them kind of a suite of tools and related concepts to that to kind of get them there. So that's the first thing. And then honestly, I do spend a bit of time at the beginning just on cartography. I find that students love map design. I don't think they realize it until they get into it. Like I try to warn them near the beginning. I say, this course can be kind of time consuming, but it's because you'll end up wanting to spend time making nice maps. And so it's another way of kind of making it more accessible to people. I think it's kind of fun to think about like, well, where should I put the legend and what color should I make this? And I don't think it's necessarily difficult for people to kind of grasp some of the basics of map design and cartography, like the really straightforward stuff. And so I want them to kind of get that feeling of, that they're creating maps. Every assignment I give students, a map is part of the final product. I want them to feel like they created something that they could show their friends or their family or whomever and say, I created this and look what it shows. So I feel like those are kind of the basics. But then as they start to get a better understanding of what GIS is, then you can start to see the wheels really starting to turn. Like, well, I could use it for this, or I could use it for that. They start looking at all the different data sources out there, or it's something they've seen in a movie, or whatever. They think about like, mapping tweets or how it relates to social media. And for me, the amazing thing is to see all of that and going back to this idea of letting them choose the data and choose the context and the subject essentially is so much fun for me, because then I get to see what they're interested in and how they see it applying to what they're learning. And so then it kind of widens out. So there's all kinds of things that they could want to learn more about. But yeah, that's kind of how I get things started, or kind of see if I can get them thinking about where they can go with it.
So that's right at the start of their educational journey. So if we fast forward now towards the end, do they feel like they're prepared for industry when they leave university, or can you see any sort of gaps in their knowledge?
It really depends on where students want to go and what they want to do for their career. I really try to spell out to students the various options that are available. I would say of the students that graduate that want to do something with GIS in their jobs, a lot of them, it's not going to be their main function. So I talk to them and I'll say, think about the job title that you're looking for. Is it GIS analyst, specialist, developer, or is it conservationist, urban planner, market research person, that kind of thing. And to kind of give them a sense of what's the emphasis, what's the focus, what kinds of competencies are they wanting to develop and make sure that they have when they graduate. And I think maybe it's just me, but I feel like there's a bit of an emphasis in the industry that there's this kind of assumption that everyone wants to be a developer, a coder, or, kind of enterprise level, high end kind of work. And yes, that is one of the paths that students can take in their careers. So we try to give them a decent grounding in, web-based GIS and data modeling, a little bit of SQL, some Python, so that they do have some of those skills as they, go forward. But as you might imagine from an academic, I also think it's important to have some of those other skills. And it's funny, I was having another look at the Geospatial Technology Competency Model, which has been around for a long time. It's by the U.S. Department of Labor, but they list different competencies that they think are important for a career in geospatial. And I always try to remind myself of some of the things that are there, like interpersonal skills, integrity, professionalism, reading, writing, math, communication, critical and analytical thinking, teamwork, creative thinking. Like there's all these things that students do develop and that we try to really help them with as they go through their university career. And it's been shown that employers really value that. They want people that have, elastic brains and are creative and are good at working with other people, tackling things in different ways. So we really try to work both sides of it. I do want them to have some really good skills. I want them to be able to feel confident that when they go out, they're going to be able to tick boxes, on an HR list of, skills that are required. But a lot of them, they're going to keep learning as they go. I think I'm not alone in this, that I think most people that work in the GIS field have taught themselves a lot of things. You have to work independently. You have to be able to kind of explore tools and, Google things and what does this thing do and why would I want to use it and what's an example, and kind of work your way through it. And being able to work independently, being able to have that critical thinking is really important. It's you have to be able to put all of that together into a package. So I feel like we try to, launch them into their careers, but with the mindset that they're going to have to continually keep learning through their careers, and that's a good thing. That's what honestly makes any job a lot more fun and a lot more interesting, is that you're not doing the same thing all the time, that you continue to grow as you move along.
Thank you very much for that. I really appreciate that, because one of the questions I get most often is this, what skills should I be learning? And I feel like people are looking for a way of hacking the system. If I just learn this one thing, then I will go on to have a successful career. But I really feel like you have listed off a lot of less obvious skills, but for me personally, I think they're incredibly important. So I appreciate you just for highlighting some of those.
One thing that I have conversations with students a lot about, they're getting ready to graduate and where are they going to go, and getting some advice, or they'll ask like, what are the kind of marketable skills that I should have? And sort of the, inevitable one that comes up all the time is Python and programming. And I'll tell them, I'll say, well, that is definitely a marketable skill. It's definitely something that you'll see in a lot of job ads. So if you haven't done any programming before, then take a course and decide if you like it. But don't go get a job doing coding if that's not something you enjoy. If you're taking a certain path or working towards certain skills just because they'll get you a job, but you don't really enjoy that work, then why would you do it, right? So I try to kind of keep that perspective for them, is definitely try things out, explore different options, see what's out there in terms of like, would I like learning? I've students who have never touched programming before. And some of them, they take Python courses and they're like, wow, this is awesome. They really get into it. Other ones are like, yeah, not for me. So you have to kind of keep that in mind, is what are the marketable skills that you're getting, and how do they align with my own interests?
Yeah, I think that's some really, really great advice. We've covered a lot of ground here, and I really appreciate your time, and I want to be respectful of it. So I just have a couple of final questions. And the first one I would really like you to try to answer is, there's a lot of things happening in the geospatial world at the moment in the industry. There's all sorts of new shiny technologies coming out. There's new applications. There's new use cases. Is there anything in particular that really excites you, that you think, wow, if I could go back in time, I would focus on that thing there. My career would be based on that.
There's a lot of things. I mean, some of them I imagine are fairly obvious, like the whole shift to web mapping. It sounds like, oh yeah, of course that's something that's happened, but it really is a big change in kind of mindset for some of us older GIS people. Is that, what I try to tell students is that if you go into ArcMap or ArcGIS Pro, the fundamental kind of way of working is with a paper map. Like you're working with a layout of something that is meant to be printed. which seems kind of old school now, right? It's like, well, yeah, but how often do those things actually get printed? Like, what are you going to do with them? They might end up in a PDF, they might get printed on a poster, but really the shift to everything being much more web oriented is a big difference. And it makes it so much easier to distribute and communicate with such a mass audience. That alone is worth a lot. And of course, all of the affordances that go along with that in terms of being able to get data, share maps, story maps. So I feel like that's something that may not seem like it's that cutting edge anymore, but has had a huge influence, I think, on the way that we all think about mapping and the work that we do. I'd say some other things that are just massive. The advent of drones, lidar, are just incredible. Like the how fast that has all come to kind of fruition. That we're at a point where the data can be processed so quickly, and we can generate 3D models so quickly that we now have phones with lidar scanners in them and things. It's just amazing to me. So this amazing volume of data and the different types of data, and that's available in practically near real time, is huge. And then along with that, of course, being able to actually analyze it, process it, do something with it, and how that relates to machine learning and AI. I think that's going to be just incredible in the future. Pattern recognition, object recognition is really exciting. There's so much that can be done with that we haven't even scratched the surface yet.
Thank you very much for sharing your thoughts on those things. Just before I let you go, perhaps you could share with the audience where they can go if they want to reach out to you, if they want to learn more about your work, or just continue this conversation.
Sure. I have a relatively unusual name, so I'm pretty easy to find online. I have a website that's donboys.com, so DONBOYES.com. You can find me on Twitter, just at donboys. So I have a YouTube channel as well. If you search that for Don Boys, you'll find me there. So those are the main places that you'll find me online. But and feel free to reach out if you want to chat.
Thanks again, Don. I really appreciate the conversation. And I just want to say, I think your students are incredibly lucky to have such a passionate educator.
Thanks so much. It's been a lot of fun. Thanks, Daniel.
So I really hope you enjoyed that conversation with Don. I just have a few things I'd really like to highlight here at the end of the episode. So often when we talk about Google Maps on this podcast, we talk about one of the big revolutionary factors of it was that Google Maps came along and it put us at the center of the map. So the map was centered around us. It was relative to us. And I think this is one of the really interesting things that Don brought up. So when he's teaching students, because we have, vastly more data than what we had before, we can tailor the solution, we can tailor the learning experience to the students simply by saying, hey, go and find some data that you are interested in. Let's map something that means something to you. And this is putting students at the center of their own learning. It's making something that's relative to them. And we're getting away from this one-size-fits-all solution. And I think this is absolutely brilliant. Often on the podcast, I have a tendency to focus on the technical, shiny things. And it was really interesting to hear Don say, yeah, that's great. I mean, learn programming languages by all means, but remember, a lot of other important skills are these softer skills, or sometimes I've heard them referred to as essential skills. And communication was a really big part of that. So can I explain complicated ideas to people? Can I make them understand how the thing that I'm doing is going to benefit them? And I think regardless of how technical our industry can be at times, we need to remember that we are by and large in the service industry. So we are making something for somebody else. We are part of the solution. We are not the entire solution. There's a wonderful quote by Arthur C. Clarke, and the quote goes like this: any sufficiently sophisticated technology is indistinguishable from magic. And I think for a lot of people, geospatial technology feels a lot like magic. So magic is amazing. We can surprise and delight people with magic. We can also get a lot of attention by doing magic tricks. But at the same time, magic feels a little bit risky. It feels like perhaps it was just a happy coincidence. Maybe it won't work next time around. And if people are perceiving our technologies, our services, and our ideas as being magical, I'm willing to bet that it is unlikely that they will want to implement them into their critical infrastructure. It's unlikely that they're going to invest significant amounts of resources into our ideas. So I think we need to find a way of communicating our ideas, of explaining the potential of the technologies that we work with, the ones that we understand, and explaining them to the people that we are seeking to serve in such a way that they can see themselves at the center of this technology. In the same way, Don found a way of putting the students at the center of their own learning. I think this is going to be really important going forward as we see more geospatial technology being implemented in different business use cases and different use cases in general. I think we need to be significantly better at explaining it to the people, at putting them at the center and making it relative to them and their business and the problems that they are trying to solve. Thank you very much for tuning in again this week. I really appreciate you taking the time to listen to these podcasts. It takes a lot of time and effort to make them, and it is incredibly rewarding to see that the community around this podcast is growing, and I am extremely grateful for that. I'm also very grateful to my sponsor for this episode, Langrid.com. Again, if you're interested in boundary data for the US, check it out. There'll be a link in the show notes. So that's it from me. My name is Daniel. It's been an absolute pleasure being your host again this week. If you want to reach out to me for whatever reason with any comments, suggestions, or perhaps direction for the podcast, you can find me on social media, and I would love to hear from you. Okay, we'll talk again next week. Bye.